It's a pleasure having you here again, my friends, on Will EduTech. Now, in this video, we'll be looking at the solution to question 10A, a typical measurement, geometry, and trigonometry question taken from the CSEC Math Exam Pass paper, January 2012. Now, in the question, let's just pull it up a bit. Now, my friends, the question states that the diagram below, not drawn to scale, shows a regular hexagon with center O and AO is equal to 5 centimeters. So here we have our regular hexagon and the center is labeled O and the length of the line segment A to O is 5 centimeters. Now quickly, some very important pieces of information that they have given us. They said that it's a regular hexagon. Now my friends, in a regular hexagon or any polygon, because a hexagon is a polygon, okay? And for your information, a polygon is a plane bounded shape consisting or having 3 or more line segments, okay? So once the shape is bounded and it's a plane shape, meaning that it's a flat shape, okay, it is called a polygon, a bounded shape. Now let's just quickly get into this. Now if you notice our hexagon here, it's regular, and the important thing about a regular hexagon is that the length of each side are the same, okay? So the length, for example, of A to B would be, and let me just quickly make a note here. Let's call this point here C, and let's call this point here D, and I'm just simply going to call this point E, and I'm going to call that point F, okay, so that you can follow when I'm talking, just to make it a bit easier to recognize which side we're speaking about. Now basically, my friends, here the length of AB would be the same length as BC, which would be the same length as CD, and which would be the same length as DE, and as so on, okay? So that's what we mean by the length of each side of the hexagon is the same, of each side is the same. Now also another important feature about a regular hexagon is that the size of the interior angles also measures the same. For example, if you notice the angle AOB, which they're asking us in part 1 here to find, AOB, the size of angle AOB would also be the size of angle BOC, which would also be the size of the angle COD, which would also be the size of the angle DOE. Okay, now so since they're asking us in part 1 now, and just quickly let's just get that out the way. Now since they're asking us in part 1 to calculate the value of the angle AOB, now I can just simply say the angle AOB, let's just make a quick statement here. Now there we have made our statement. Let X represent the angle AOB. Okay, now basically what we have just gone through, my friends, if the size of angle AOB is X and we have just established that each interior angle is the same, then if AOB, and this is the angle AOB, and let me mark it here, let me just mark it in yellow there, that's the angle AOB. If this is X, my friends, and we have already established that each angle, this angle must be the same size as this angle, then also if the size of each angle is the same, then we could also say then that that angle is X. Also, my friends, we could also say that this angle is X because all of the interior angles must be of the same size. Okay, so that angle is also X, and the size of this angle, my friends, is also X degrees, and also the final angle here will also be X degrees. So basically what we are saying, all of these angles here, this angle plus that angle plus that angle plus this angle, if you notice, all of these angles surround a common point O, and we would have already learned that angles at a point sum to 360 degrees. So if each individual angle, if the size of each individual angle is X, then I could also write an equation to represent that information. I could say X plus X plus X plus X plus X, and I should have 6 X's here. 1, 2, 3, 4, 5. I need another one. plus x, because each angle, and if you count all the angles, we have 6 angles. We have 1, 2, 3, 4, 5, 6 angles with sizes x degrees. Now when we add up all those 6 angles, you know that's angles at a point, so we should get a total of 360 degrees. So basically what we could do, we could collect our like terms by saying this is x plus x plus x, and if we have 6 of them, we just add them up. So we have 6x is equal to 360 degrees. Now if you notice, 6 is multiplying x, so by transposition we could simply divide through by 6. Okay, so 6 will cancel 6 there. So basically I'm saying 6 into itself goes once, 6 into 36 goes 6 times. So basically my value for x is equal to 60 degrees. Okay, now we can make a statement, because this is a geometric concept. We can say angles at a point sum to 360 degrees. So now my friends, there we have it. The value of x is 60 degrees, so we have stated our geometric reason. Angles at a point sum to 360. So now therefore, since they had asked us to find the angle AOB, we can say therefore the angle AOB is equal to 60 degrees. Okay, and that's an easy 2 marks. Now quickly let's get into part 2. They're asking us to calculate to the nearest whole number the area of the hexagon, and that's another easy 3 marks. Now let's just quickly get into that across here. Now the area of the hexagon, now basically if you notice, the hexagon is divided into, let me just take my pointer, the hexagon is divided into 1, 2, 3, 4, 5, 6 triangles, and we can simply say these triangles are congruent. And what do I mean by congruent? The word congruent simply means the sizes of the triangles are the same. So each triangle have the same size, and each interior angle would measure the same, and each corresponding line segments would also measure the same. So that's what you mean by congruent. You basically, it's like you having twins or triplets, you know guys. If you have a twin brother or a twin sister, basically you would look alike. Not in all cases though, but I'm speaking about identical twins now. So basically that's what we are saying. Each triangle, they have the same size, they look alike, they're typically identical. All right, now having said that, now basically if they're asking us to find the area of the hexagon, it would simply suggest, if I have the area of one triangle, since there are 6 triangles, then we could simply again multiply the area of the one triangle that we have found by 6 to get the area, the total area of the hexagon. All right, so with that said, let's just make a quick note. First, what I'm going to do, I am going to find the area of triangle AOB. Okay, so let's just make a note here. Well, here we have it, my friends, the area of triangle AOB. We have made that critical note. Now basically if you look at the triangle AOB, and let me grab my pointer, AOB, if you notice, basically AO, they gave that to us to be 5 centimeters. So also BO, since it's a regular polygon, the length of AO would be equal to the length of BO. Okay, so since we can make that statement, AO, the length of AO is equal to the length of BO, which is equal to 5 cm. Okay, because we had established that these two triangles are congruent. 5 cm. Now basically, to find the area of that triangle, given the fact that we have 2 sides that forms the angle at the point O, since we have AO, which is 5, and let me run my pointer along that, AO, which is 5, we would have this value here to be 60 degrees, and let me just put that in. We have just calculated this value to be 60 degrees. So, and if you notice this point here, BO would also be 5 cm, as we have stated. So these 2 sides, my friend, AO and the side BO, forms the angle at the center there, which is 60 degrees. So basically, when you have a situation like that, you can use the sine formula to find the area. Okay, you have 2 sides sandwiching an angle in between. So therefore, I can simply say now, my friends, that the area is equal to, the sine formula says, half of AB sine C. Okay, now basically what is happening here, I'm finding the area which is equal, and remember it's the area of triangle AOB I'm finding. So basically I would have a half times A, and A could be represented as this side, A to O, so that's 5, and B to O is also 5, so I'm just substituting those values, also 5, times the sine, and the sine is really the angle that is in between here, which is my 60 degrees. Alright, now basically let's just quickly calculate this. We have 5 times 5, which is 25. 25 times a half is the same as 12.5. Okay, hope you're seeing that. 5 times 5, that would give us a 25, and a half of 25 would be 12.5, and I'm multiplying that by the sine of 60 degrees. Now the sine of 60, my friends, is really 0.86603 correct to 5 decimal places, and you could just plug that in your calculators. Okay, just press the sine button and then press 60. So basically what I have left here is really 12.5, and that is multiplying, and I've just found the sine of 60 to be 0.86603 correct to 5 decimal places. And the reason why I've used 5 decimal places is because in the end I don't want it to throw out my final answer. Okay, so please do not use 1 or 2 decimal places. Please use approximately about 4 to 5 dp. Okay, so basically 12.5 rather times 0.86603 is equal to 10.83. so this works out to be 10.83 centimeters squared. And since this is the final answer for my triangle, because remember it's the area of triangle AOB I am calculating, I've just leave that to 2 decimal places. Okay, so now we're going to go into calculating. Since we found the area of one triangle, then since we have 6 of them, then we can just simply multiply the area of this one triangle by 6 to get the area of the hexagon. Good. So now my friends, the area of the hexagon would be equal to, so my area would be equal to my, since it's 6 triangles, I'm going to simply say 6 times the area of one triangle, 0.83, and that is equal to, and basically we would get a 64.98, okay, when we multiply that. But because they have stated here that in the instructions here at the bottom that they want our answer to the nearest whole number, okay, the area of the hexagon should be to the nearest whole number. We're simply going to look at the in our whole number. If you notice 64.98, the whole number portion of that basically would stop before the decimal point here. And if you notice, I've put a red marker above my 4. So since that's the last number that would make up the whole number before you reach a point, then simply what I'm going to do, I'm going to look to for the next digit that is that follows the point. That's a 9. If it's 5 or more, I'm simply going to add 1 to the 4, okay, or to any value that's there. So 1 plus 4 would give us a 5. So basically our answer would be 65 centimeters square to the nearest whole number. So this is the area of the hexagon. Hope this was helpful, and stay tuned for part B, question 10, in the next video. Bye.